okay, vitamin B2. So the riboflavin through its coenzyme, so it is also it also has a coenzyme action. So through its coenzyme, it takes part in a variety of oxidation reduction reaction. So if you notice, one single vitamin is not performing only one single function. They have a multiple metabolic functions. So similarly, riboflavin through its coenzyme, it takes part in variety of cellular oxidation and reduction reactions. So what is its chemistry says? Okay, so this is B2. The meaning is yellow enzyme. This is present like yellow color, and it is therefore called as a yellow enzyme. So riboflavin contains three linked membered rings with a sugar alcohol attached to it. Okay, and sugar alcohol attached to a middle ring. In stomach, it is released from bound form by hydrochloric acid. It is absorbed through facilitated diffusion and transported in the blood by protein carriers, converted to coenzyme form in the small intestine, heart, liver, kidneys. So high intake causes bright yellow urine that glows under UV light. So the riboflavin contains basically 6,7 dimethyl isoalloxazine. Okay, a heterocyclic three ring structure. So this three ring structure is attached to ribitol. Okay, ribitol, and by a nitrogen atom. So this, you see nitrogen. So this is attached to a ribitol by a nitrogen atom, and ribitol is basically, you see, open chain form of a sugar. Okay, it is an open form of a sugar, ribose. Okay, that is why the name has come. Ribose with the aldehyde group. You see this CHO group. Okay, aldehyde group CHO, which is reduced to CH2OH. CH2OH. Okay, so basically this riboflavin has these dimethyl isoalloxane, or you can also call it as a heterocyclic three ring structure, which is attached to the ribitol by the nitrogen atom. Ribitol is an open chain. This is an open chain form of a sugar. Which is that sugar? It is a ribose sugar with the aldehyde group, that is CHO, which is then reduced. Okay, this is an oxidized form. It is reduced form to alcohol sugar, that is CH2OH. So this riboflavin is stable to heat, but it is very sensitive to light, and when exposed to ultraviolet light or ultraviolet rays of sunlight, basically it gets converted and degraded. We will see that in detail. So this riboflavin through its coenzyme takes part in a variety of oxidation reduction reaction, and yeah, so it's yeah, actually it is a stable. I have typed it, so made a mistake. So this riboflavin is a stable compound to heat, but highly sensitive to, and when it is exposed to ultraviolet light, thus it is converted to this lumiflavin. Okay, lumiflavin, which exhibits the yellow fluorescence. The substance, namely lactoflavin, so basically the substance is namely this lactoflavin present in the milk, or hepatoflavin from the liver, or ovoflavin from the eggs. Basically, these all three of them were considered like originally thought to be different, but they are identical to riboflavin. Okay, so this there is a this flavin mononucleotide, that is FMN, and flavin adenine dinucleotide, that is FAD, are the two coenzyme form of riboflavin. And this ribitol, that is a 5 carbon, is linked to phosphate, linked to this phosphate. You see this phosphate uh, in FMN, that is flavin mononucleotide, and this FAD is formed from the flavin mononucleotide by the transfer of AMP moiety from the ATP. So if you see the riboflavin gets reduced to form this FMN, and then it gets further reduced to FAD, and this coenzyme has lots of applications or functions like antioxidant defense, DNA repair, protein binding, apoptosis, chromatin remodeling, ATP production, and so on and so forth. Okay, so this that is FMN, that is flavin mononucleotide, and flavin adenine dinucleotide are very very important two forms of these coenzyme forms of this riboflavin. Please remember. Okay, and now what are the like its occurrence in the food? The RDA, or recommended daily allowance for this vitamin, is 1.3 milligram per day for men, whereas 1.1 milligram for women, and average intake is around 2.1 milligram per day in men, like and women. So this is found in green leafy vegetable, liver, mushrooms, low fat milk, cottage cheese. If you see liver consumption will meet more than 170, because it will have 1.3 milligram consumption of 3 ounce of beef liver will meet your more than 171 requirement, 1% RDA. Okay, so it is also present in fermented products like yogurt, and then cottage cheese, which is fermented again, low fat milk. So cheese can meet almost 25 to 30%. Okay, so there was a study in which this riboflavin distribution in fresh human and cow's milk was studied. So these are the content with respect to human milk, and this is with respect to cow's milk. So the human milk is rich in this coenzyme FAD, whereas cow milk has around 23 to 46%, and riboflavin was found less, that is 31 to 51, compared to the cow's milk. So and then other flavin forms are found in the traces. So basically, as I said, this riboflavin gets degraded because of the light. Now it is quite stable in the heat, but it is highly sensitive to light. So two biologically inactive forms are formed, that is lumiflavin and lumichrome. So this photolysis of riboflavin yields superoxide and riboflavin radicals, and when these radicals are formed, they can be very dangerous in our body. So reaction of oxygen with this riboflavin radical provide the peroxy radical, and then you know that what reaction happens when you have this peroxy radical, and once the more free radicals are generated in our body, then you know that this is not good. So there are a lot of biochemical functions this flavin or riboflavin enzyme performs. So the flavin coenzyme, mostly FAD, and to a lesser extent FMN, both of them participate in many redox reactions which are responsible for energy production. And the functional unit of both the coenzyme is, what is the functional unit for both coenzyme is isoalloxazine ring that we saw na, which serves as an acceptor for the two hydrogen atom, this okay, this ring. So this accept the two hydrogen atom. So you see, yeah, here you it has accepted. Okay, so this flavin coenzyme participate, and then isoalloxane ring accepts the hydrogen, forming the FnH2 or FADH2. Okay. Uh, so further, the functional unit of both the coenzyme is, so here enzyme that use flavin coenzyme are called as a flavoprotein enzyme. So FMN or FAD undergo identical reversible reaction. This reaction is reversible. Okay, it can take, like, gives rise to 2H plus also. So this is a reversible reaction accepting two hydrogen atom, forming then FMNH2 or FADH2. Okay. So enzyme that use this flavin coenzyme FMN or FAD are called as a flavoprotein. So the enzyme that are use this flavin coenzyme, they are called as a flavoprotein. The coenzymes, that is prosthetic group, often bind rather tightly to this apoenzyme by non-covalent bond or covalent bond. Okay, and they form the metalloflavins. Metalloflavins. So these many flavoproteins contain metal items like iron, molybdenum, which are known as metalloflavoproteins, and the coenzyme FAD and FMN are associated with certain enzymes involved in carbohydrate, lipid, protein, purine metabolism, and most importantly, electron transport chain or electron transport system. So what are the functions of the riboflavin? So basically riboflavin is converted into molecules which acts as a coenzyme. Just now we saw that, and these coenzymes act in a variety of metabolic reactions. It is required for the formation of flavin adenine nucleotide, that is FAD, mononucleotide flavin mononucleotide, that is FMN, and these two are used in redox reaction in Krebs cycle or a succinate dehydrogenase cycle. So this FADH2 that is formed is one of the fuel for electron transport system. Just now we saw how it acts as an electron transport system. They are also required for fatty acid breakdown. It is called by a pathway of beta oxidation, acetyl coenzyme, that is fatty acyl dehydrogenase. So this FAD is specially needed for formation of niacin enzyme from tryptophan. So if you consume tryptophan, you will need this FAD for formation of niacin. FMN needed for formation of uh, active version of B6 coenzyme, that is pyridoxal phosphate. We will see. So this enzyme is also needed. This vitamin is also needed for making of other vitamins like pyridoxal, that is B6 vitamin and niacin vitamin. Like, so these riboflavin participate also in the folate metabolism. Okay, it's very very important. So a person who is deficient in riboflavin will also find deficient in niacin or B6 or folate, because it participates in also folate metabolism. So synthesis of antioxidant compound glutathione also depend on FAD containing enzyme, that is glutathione reductase. So this riboflavin deficiency results into many symptoms like it is called as a cheilosis, which is nothing but the fissures. You see there are fissures at the corner of the mouth, they are observed. Also the tongue becomes smooth and purplish or blackish. Here the colors are not seen, but this is called as a glossitis. Also dermatitis, a severe dermatitis, and the dermatitis is mostly seen along with the other vitamin deficiencies. Alcoholics are susceptible highly to deficiency, as we have seen. A riboflavinosis, which develops 2 months after cessation of riboflavin. So symptoms could be inflammation of the tongue, cracking of tissue at the corner of the mouth, that is angular cheilitis, or seborrheic dermatitis, nervous system disorder like anemia, fatigue, confusion, headaches, tiredness, and mostly if the person have diabetes, cancer, or cardiovascular, the symptoms becomes even worse. The next vitamin in this series is a niacin vitamin. Niacin, it is also called as a nicotinic acid. Okay, this enzyme, this vitamin is also called as a nicotinic acid. Also, it is called as a pellagra preventing vitamin, PP, pellagra preventive vitamin. Okay, uh, pellagra preventive vitamin of Goldberg. So basically, Goldberg was a scientist who discovered. So this niacin or nicotinic acid, the coenzyme of niacin, that is NAD plus and NADP plus, can be synthesized by the essential amino acid tryptophan. Okay, so amino acid or protein consumption is very important. The disease pellagra, in Italian, it is in the Italian language, the pellagra means rough skin. So in the pellagra disease, the skin becomes very, very rough. Its relation to deficiency of dietary factor was first identified by the scientist Goldberger, who conducted experiment, and his associated conducted a very, very important and very interesting experiment. And what was that experiment? While I was reading, so for this testing, only testing. See, during those days, it was not a practice to follow the ethical systems or ethical things, especially for the prisoners. So prisoners, in this case, 12 prisoners were promised pardon. Okay. If they consumed the diet of the these pelagious families of 1 year. So this Goldberg promised that in this research he is going to feed this prisoner with the diet which will cause pellagra. Okay, and then if they accept that, they will be pardoned from their punishment. Okay, and that too they were fed for 12 months, like almost a year. And then the diet consisted which food? Okay, so only pure corn. It was like a corn meal, not corn, a whole corn, but a corn meal. Then corn starch. Sorry, this is corn meal. Then corn starch, like pure starch. Then only rice, only starch containing compound were fed. A sweet potato or potato. Okay, only starch and fat, a pork fat. Okay, pork fat, pure pork fat. So they were only given rice starch, corn meal, sweet potato, and pork. And you will be surprised to see the result that the subjects or the prisoners showed symptoms of the pellagra within 6 months. Not even, see, the study was agreed for 12 months, but less than 12 months, within 6 months only, the prisoners developed the symptoms of the pellagra. And and there was also control group in which the prisoners, the another control group of prisoners, were fed with the regular diet. Okay, regular diet with the whole grain and all sort of things. So, and then in the next third stage, and these prisoners were normal, they did not show any symptom of pellagra. In the third case, these prisoners who showed pellagra symptoms were fed with the liver, and the pellagra got cured immediately. Okay, so the liver cured pellagra immediately. Okay, so this was a story, and that is why this vitamin is also called as a pellagra pp Goldberg. Okay, pellagra Goldberg, because of the Goldberger invention on this. So it was recognized as a vitamin, or nicotinic acid was well known as a chemical compound produced by the oxidation of this nicotine. But the term niacin was coined, and more commonly it is used for the nicotinic acid, and this was done to emphasize the role of niacin as a vitamin and then avoid any confusion with this nicotinic acid, that is an oxidized form of nicotine. Okay, but then niacin or niacin should be used as a name. Okay, so what does its chemistry says? So niacin is basically a, if you see this niacin is a pyridine derivative, and structurally it is a pyridine 3 COOH. You see this carboxylic. So this is your COH, carboxylic acid. The amide form of niacin is also known as a niacinamide or nicotinamide. Okay, a reduced form. So nicotinamide linked to adenine dinucleotide or adenine dinucleotide phosphate, or in the form of oxidide. So coenzyme forms using nicotinamide. So dietary nicotinamide, niacin, and tryptophan, an essential amino acid, both contribute to the synthesis of the coenzyme called as a nicotinamide adenine dinucleotide, NAD plus. Okay, NAD plus. So how does this NAD plus is synthesized? So basically there is a long pathway. I'm not going to explain. So there is a whole multi steps biosynthesis pathway of nicotinamide nucleotide, that is NAD plus, from the these various like niacin and. So there are like many in which this niacin and tryptophan, which is an essential amino acid, they contribute the synthesis of this NAD plus and NADP plus. Okay, so this NADP plus is nothing but nicotinamide adenine dinucleotide phosphate. The pathway for this biosynthesis, and that I'm not going to explain. So this nicotinamide is basically in this pathway deaminated in the body. Okay, and then the further process takes place. Okay, so see, this is a nicotinic acid, nicotinamide, and a nicotinamide adenine dinucleotide, and then so both this NAD and NADP both function as coenzyme in the transfer of reducing equivalent in many dehydrogenase reactions. Heat, especially under acid or alkaline conditions, converts this nicotinamide to nicotinic acid without loss of vitamin activity. So both of them have a very good vitamin activity. This niacin is not affected by light, and no thermal losses occurs under conditions relevant to food processing, but the losses can occur during leaching, washing, bleaching, blanching, processing, preparation, or exudation of fluid from the tissue. It is called as a drip loss. For example, you have these leafy vegetable, okay, and then if you keep this leafy vegetable in the deep freezer, okay, so the tissues are frozen, and then when you thaw them, the drip loss takes place, or exudation of the fluid from the tissues comes because of the damage to the tissue because of the ice formation. So distributed vegetable foods of the animal. So diet high in protein reduces the requirement of niacin, because we have seen the protein requirement through metabolic conversion of tryptophan to nicotinamide. Okay, so there are multiple functions, this biochemical function, this coenzyme NAD plus and NAD plus are involved in, for example, various oxidation reaction, oxidation as well as reduction reaction that take place. They accept hydride ion, that is hydrogen atom, in one electron system, and they also undergo reduction in the pyridine ring, and this result into neutralization of positive charges, the nitrogen atom. So lot of oxidation reduction reaction they undergo. Okay, oxidoreductases. So if you see these cycles in lot of oxidation and reduction reactions, you see that your NAD plus and NADH, they get oxidized, reduced. So many places they are required, and without them these things will not happen. Okay, the many this. So what is the occurrence of this niacin? Recommended daily allowance or dose for niacin is around 16 milligram per day in men, whereas 14 milligram per day in women. Okay, and for children it ranges between 10 to 15 milligram. Very often the term like niacin equivalence is used, basically for expressing the RDA, because one niacin equivalent is equal to 1 milligram of niacin, or 1 milligram of niacin, 1 milligram of niacin, or it is also called as a 60 milligram of tryptophan. Okay, one niacin equivalent is equal to, okay, so that is called as a niacin equivalent. So pregnancy, lactation in women impose on additional metabolic burden, because lot of metabolic reactions happens during pregnancy, lactation, so therefore an additional reaction or additional requirement for this niacin increases. So there are multiple number of dietary source. The rich natural sources of niacin include liver, yeast, fermented product that are prepared from yeast, whole grain, cereals, pulses, beans, then peanuts, milk, fish, eggs, and various vegetables are very, very good as well as moderate source. The essential amino acid that you, if you consume essential amino tryptophan, that can serve as a very good precursor for the synthesis of this nicotinamide coenzyme. So on an average 1 gram of a good quality protein. So we know that a see what is the protein. There are two types of protein: good quality and low quality. Good quality means the balance of essential amino acid. So if you consume a good quality protein, for example egg is considered as a very good, or whey protein. So 1 gram of good quality protein contains about 60 milligram of tryptophan, which is equivalent to basically 1 milligram of niacin. So if you converge, like here the conversion ratio is 60 as to 1. Okay, this tryptophan to niacin. So 60 milligram of tryptophan is coming from 1 gram of good quality protein. So 60 milligram of tryptophan is equivalent to 1 milligram of niacin. So for the synthesis of nicotinamide coenzyme, so tryptophan is very, very important. Okay, that plays a very, very important function in the body. So dietary tryptophan cannot basically replace that, we will see. Okay, so this niacin equivalent used while expressing its recommended daily allowances. So one niacin equivalent is equal to 1 milligram niacin or 60 milligram of tryptophan. So tryptophan has many other functions in body. Therefore, dietary tryptophan cannot totally replace. So you will say that okay, my body must be having tryptophan, I will not consume niacin. But then tryptophan cannot totally replace niacin. Increased conversion of tryptophan. Suppose you do not consume niacin. So what body will do? Body will tryptophan to niacin. So increased conversion of tryptophan to niacin, when does it occur? If you do not take protein in diet. Okay, so low protein in diet, or people are crazy, they do starvation a lot because of rituals or whatever reason. So if the person, or some people in our country also do not get food, they have to sleep hungry stomachs, and then there is a starvation. So low protein diet and starvation results into conversion of tryptophan to this niacin. So tryptophan can replace niacin to an extent to only 10%. Okay, for the synthesis of coenzyme. Therefore both niacin and tryptophan have to be invariably provided in the diet. Okay, you cannot skip. So how does the losses takes place? So cooking causes changes in the concentration of niacin compound through interconversion reaction. For example, if you heat the vegetable or fruit, this heating causes release of free nicotinamide from the NAD and NADP during the boiling. Suppose corn are very rich, whole corn, okay, corn grains. In addition, the distribution of niacin compounds within a product varies as a function of variety, like sweet corn versus field corn. There are in in sweet corn also there are variety, stage of maturity, all that factors affect. So bioavailability of this NADH is reduced form of NAD, and presumably NADPH exists very low bioavailability, possesses very low bioavailability because of their instability in the gastric acid. We know that the gastric acid environment is highly acidic, so therefore it is like its bioavailability is poor compared to others. So analysis of this is important because when as a food scientist, when you go to the industry and when you want to retain or restore the more thiamine in canned corn or peas or vegetables, so that time you need to understand how one can analyze. So a reaction of niacin with cyanogen bromide to yield an N substituted pyridine, that is then coupled to an aromatic amine to form a chromophore, and then this chromophore can be then measured either in the form of absorbance or fluorescence, or you can use another methods like HPLC or gas chromatographic method for measurement of nicotinic acid and nicotinamide in the foods. So what is the deficiency? Niacin deficiency result in the condition well known is called as a pellagra, and the pellagra meaning I already explained. It is called as in Italian language. It is called as a rough skin, and this disease involves skin, gastrointestinal tract, central nervous system, and the symptoms of the pellagra are like you can remember 3D, okay, or 4D maybe 3 or 4D. If you want to remember the symptoms, 3D, you call them as a 3D or 4D symptoms. Okay, so this is also progresses like it is also progressive report. Like initially you will see dermatitis, then diarrhea, then dementia, and then death. Okay, these symptoms are progresses in that order only. Okay, and if treated, if not, here 3D you remember, and if the treatment gets, then the person will not die. But if not treated, death occurs. Okay, it is called as a fourth D. Dermatitis, what is the dermatitis? Inflammation of skin is usually found in the areas of the skin that are exposed to sunlight, like basically neck or dorsal part of the feet or ankle or part of the face. So diarrhea may be in the form of loose stools, often with the blood or mucus, and prolonged diarrhea leads to weight loss, dementia, and and it is also associated with the degeneration of nervous system. We know that dementia is associated with the degeneration of the nervous system or nervous tissues, and the symptom of dementia include like anxiety, a person feel very irritable, poor memory, insomnia, you will not get sleep at all, like sleeplessness. There are so many people in the country who have this dementia or sleeplessness or anxiety, and particularly in this pandemic, such of course it is because of the mental disorder, but we cannot reject the cause of even deficiency of the vitamin, so insomnia or sleeplessness, etc. So this pellagra is mostly seen among people whose staple diet is only corn or maize and no other cereal grain, and corn doesn't have niacin. So niacin present in maize is unavailable to the body, as because it might have the thiamine or this niacin, but it is in the bound form. This bound form is not at all available. Further, the tryptophan content in the corn is negligible or very low, so you are not even getting tryptophan. Okay, you will think that through tryptophan because the ratio is quite like low, like so it is very poor. Okay, so conversion ratio to tryptophan to niacin, because corn doesn't have even tryptophan. Okay, so this is like the condition of dermatitis where neck and the area which is exposed to the sun will be affected due to this condition. Okay, there are therapeutic uses of niacin, that is administration of niacin in a pharmacological doses like 2 to 4 gram per day, which is almost 200 times the RDA, which results into number of biochemical effects in the body not related to its function as a vitamin. And most of the effects are believed to be due to the influence of niacin on this cyclic AMP levels. So there are like, what are those therapeutic uses? Like niacin inhibits lipolysis in the adipose tissue and decreases the circulatory free acid system, or triacylglycerol synthesis in the liver is decreased. The serum level of LDL, that is low density lipoprotein, or VLDL, very low density lipoprotein, triacylglycerol and cholesterol are lower. This is very important. Okay, so hence niacin is used in the treatment of hyperlipoproteinemia. Okay, in this case what happens, there is a, in this situation, a person having hyperlipoproteinemia elevates the LDL and VLDL level. So this to reduce this LDL and VLDL level, niacin is used. So although mega doses of niacin are useful for the treatment of this hyperlipoproteinemia or hyperlipidemia, but there are certain harmful effects also. Like, see, in the therapeutic uses you are using niacin to reduce the LDL and VLDL, but then mega doses may be useful, but then there are adverse effect also. And what are those adverse effects? The glycogen and fat reserve of the skeletal and cardiac muscles are depleted. There is a tendency for increased level of glucose, increased level of uric acid in the circulation, and that might result into even the worse situation. And if you do not stop there and there itself, the prolonged use of niacin result into again elevated level of certain enzymes, suggesting there is a liver damage. So more consumption of niacin as a therapeutic use may result into liver damage. Okay, so upper limit is around 35 milligram per day, but 1 to 2 gram is given in time release form. Okay,